Hi, everybody. We're about to start our next session, if I can quieten the room. And I'm going to hand over to Scientific American for another fantastic session. Thank you.
Good morning, everyone. Thank you for joining us. My name is Kate Wong, and I'm an editor and writer at Scientific American magazine, where I cover evolution and ecology. Today, we're going to be talking about the fossil record and how it can help us face the challenges of the current climate crisis. History, we know, is essential for understanding the present and for helping us to imagine and build a better world. The same can be said for prehistory, deep time. By studying the fossils of organisms that lived thousands, millions, and billions of years ago, scientists can reconstruct the history of life on Earth and how it adapted or faltered in the face of major environmental upheaval. We know from the fossil record that on several occasions in the past, large numbers of species died out. During mass extinctions like the one that wiped out the non-bird dinosaurs 66 million years ago, between 50 and 90% of species perish, which is kind of an amazing, terrifying thing to think about. There have also been significant extinction events more recently. Between around 50,000 and 5,000 years ago, most of the large mammal species on Earth went extinct. When I say large, I mean animals that are over about 100 pounds or so, I think is the cutoff. So earlier major extinctions, such as the one that killed the dinosaurs, happened long before the origin of humans. But the decline of the Ice Age megafauna, things like woolly mammoths, woolly rhinoceroses, that took place at a time when not only climate was changing, but humans were spreading across the globe. For decades, researchers have worked to figure out what happened to these charismatic mammals, why they went extinct, and whether humans might have had a hand in their decline. Joining us this morning is Dr. Lori Bettison-Varga, president of the Natural History Museums of Los Angeles County. Among her many responsibilities is oversight of the famous La Brea Tar Pits fossil site, which contains a wealth of clues to this long-standing mystery of the disappearing megafauna. Lori, thanks for being here today.
Thank you, Kate.
So in the time that I've been covering evolution, which is about 26 years now, I think when I first started out, this idea of fossils as not only time capsules, but in a way, a crystal ball used to sound like an aspirational proposition, a nice talking point, but really was it going to happen? And now I'd say in the past decade or so, just based on conversations I've had with the scientists in my circle, it sounds like it's kind of happening. And so I'm just wondering, Lori, if you can give us a sense of what's changed. Do we have just more evidence now, better techniques now? What is changing to make this like a real thing?
So I think, well, first let's step back on the large picture, because you talked about extinction events, and we have had 5 mass extinction events. And I think that the real message and how it relates to today is the fact that, yes, we've had extinction events. Most of those have been climate related. 4, 5, the dinosaur one was an asteroid. But all these extinction events caused catastrophic changes to flora and fauna on the planet. And we've been recording that. I mean, geology, paleontology, this is the study of the Earth's history. And I think what we need to understand today is that we are another species on the planet that is going through rapid changes. And that's what we learned from the fossil record. So I think the technologies that used today can help us extract information from the fossils in ways that we couldn't in the past. So we have a little bit more detail, particularly when it comes to dating, that helps us. But we're also understanding, because of course geology and paleontology they're trying to understand the Earth as a whole. And we've been talking about that today, right? And climate is not a singular, there's no singular cause. So trying to extract that information is what geologists do. I think, like I said, technologies are different today. And that has helped us get more information. And the way we're viewing things are different. And we can talk specifically about La Brea in that regard.
Yeah, great. So I mentioned that Lori oversees the famous site of Rancho La Brea. Is that the right name? Okay.
We call it Rancho La Brea, and there's actually a time era, there was a period of time labeled Rancho La Brea in the geologic timescale.
Great. And it's a really special place. I haven't been there. It's on my list of places that I must visit because it sounds so incredible. And just tell us a little bit about that site for people who haven't been. It's in Los Angeles?
Yes, so it is in LA. It's between downtown and the beach, so it's right in a residential area with business and cultural entities. It's where tar is seeping to the surface entrapped flora and fauna over a period of time from 55,000 years ago, and actually we still have events today. And it's there because at one time, the place we know as LA today was underwater. Oil formed as the mountains were rising, and we've got sediment shedding out, so there's oil at depth, and it seeps, the asphalt seeps up to the top, and the lighter aspects evaporate. And so there's this sticky stuff that's covered with leaves and water, and you can imagine, an animal going over thinking there's water and getting stuck in the tar. And that animal might look attractive to a carnivore, and that carnivore will jump on and get stuck in the tar. So you basically have these heaps of animals and then plant material that is falling into the asphalt and getting trapped. And so the way we like to tell people to get a feeling for this is, 15,000 years ago, Los Angeles was the Serengeti with larger animals. Mammoths and mastodons, camels, horses, bison, ground sloth, but also a very rich woodland ecosystem.
So completely different.
Completely different.
Every way from how it
and
is.
that's what our scientists, Drs. Emily Lindsay and Reagan Dunn, along with their collaborators, have been studying. So what happened to these animals is kind of the question that people have been trying to answer for over 70 years. When these animals went extinct, was it because the climate had changed, or was it because humans had overhunted? And we like things that are like this or that, right? So what they did was they got a lot of dates from specimens, I think over 165 dates, using radiocarbon dating. And they identified a period of time that these they dated 7 different species, that most of the large animals went extinct. And that period of time, about 13,000 years ago, correlated with when humans were coming into the environment. And we know that from archaeological studies. But the other thing it correlated with, surprisingly, is soot records. So you can look at soot amounts in Lake Elsinore sediments and see that there was very little record of soot until this around 13,000 years ago. And that's when a lot of soot shows up. And so they correlated wildfire, humans, and the extinction of these megafauna, as well as a state shift from this woodland environment to this fire-resistant chaparral that we have today.
I mean, that's amazing because that debate has been running for decades over what killed those amazing megafauna and the overkill versus the climate change scenarios. And now it seems like, at least for this particular window, it looks like, yes, humans, but not in the way necessarily that was thought, not killing, but through fire.
Changing a state shift in the setting, right? So they've shown that the herbivores actually went first as that climate was shifting, and then the carnivores were the last to go extinct. But the wily coyote made it through. And so I think that is part of the lesson of the tar pits, is understanding what animals and what plants are no longer in this area and what survived. So at the tar pits, we also have the 5 cats, great cats. Saber-tooth, of course, is one of those. The American lion, which is larger than the African lion, now extinct. There's one left, and it's the mountain lion. And we know that we have real problems with looking at their survivability is an issue for us in LA. Wildlife bridges and whatnot are being put in place. But we have that kind of information now to be able to say what survived, what didn't. what migrated, what had the time to migrate. And I think the other point that we're learning is a shift in temperature over 1,000 years, and you see a very dramatic shift in just 100 years today. So the rate of change can be benchmarked. And I think that is the lesson we need to have today. We think we're here today, we know what happened in the last 100 years, we can think about the future. But geology gives us a lens into humans' specific impact and how we are affecting the rate of change.
Yeah, that's really something to think about. How does it bear on what's happening in Southern California today, in other parts of the world that are dry and have issues with fire, and of course, you know, everybody's feeling toastier with rising temperatures. So, you know, how do you sort of take the lessons from La Brea and other sites where we have windows on what happened that caused extinction, and sort of, I don't know, apply that
Yes.
to real world solutions for the current climate crisis?
So I want to back up and say that the way that we're viewing the work at La Brea is different than even 10, 15 years ago, looking at the ecosystem as opposed to, you know, just focusing on megafauna. And so as we're learning more about that ecosystem, we can apply those learnings, and that work is beginning to be done. Our team is working with policymakers in LA, providing information about, you know, resilience, what plants are resilient, what kinds of things should we be thinking about as we're planting zones in LA. But there's a lot more that can be done, and that's where our team is building partnerships and thinking about the ways that we can connect to really extract the learnings to be able to apply to create a healthier environment, a healthier planet. The species are healthy if the planet's healthy. We're healthy if the planet's healthy. The whole ecosystem needs to be attended to.
Right. And I know public outreach is a major sort of passion of yours, and certainly part of your mission at the museum, at the Tar Pits. And I know you're going through a process of reimagining what that can be like. And so tell us a little bit about your vision for that, and you know, why people should come visit, what you want them to take away from a visit to a place like that.
It's the only place like it in the world. It is the most significant collection of Pleistocene fossils anywhere. It really is like the Lascaux Caves, right, of paleontology. So we have a museum today. It's been there for 50 years. It doesn't tell the full story, and it doesn't connect as well to, you know, the outside locations. So I think the audience needs to know that, you know, this museum that's there has to be there. It's the only one that has to be there, actually, because the tar pits are there. So you can actually see the process of science. And so what we're trying to do with the Reimagining is link the indoors and outdoors. This is a continuum story. Help people understand that these fossils, this collection of over 3.5 million objects and specimens came from this location, this site, and how important it is to the world, so that we can have people experience the pits, the research outside, the excavation, and then to see the process as it follows into the work that's being done, and to actually help people have a sense of awe, right? I mean, I think that as we're talking about climate action today, reaching people through this sense of, wow, this was here, and you know, maybe 13,000 years ago wasn't that long ago, and what can we learn about today from that past? So we want to be able to tell that story. We want to bring people in, engage them, help them experience the Ice Age in Los Angeles, and really think about how that applies to their actions and what they can be doing today. It is just an incredible story to be told, and you know, we think it really will, and it does. It impacts people's hearts.
It sounds phenomenal, and I can't wait to visit and see what you do with it. Thank you, Lori, for being here today.
Thank you, Kate.